Mir is a self-propelled deep submergence vehicle. The project was initially developed by the USSR Academy of Sciences along with Design Bureau Lazurith.Later. Two vehicles were ordered from Finland. The Mir 1 and Mir 2, delivered in 1987, were designed and built by the Finnish company Rauma-Repola's Oceanics subsidiary. The project was carried out under the supervision of constructors and engineers of the Rzeszów Institute of Oceanology. Characteristics: the vessels are designed to be used for scientific research. They might also be used to assist in submarine rescue operations, although they do not have the capacity to take anybody aboard when underwater. The carrier and command center of both Mir submersibles is the USSR Academic Slavkeldich. The two Mir units are operated by the Russian Academy of Sciences. The Mir submersibles can dive to a maximum depth of 6,000 meters. Traditionally, the personnel sphere of a deep-sea submersible is manufactured of titanium plates that are welded together. On Mir, the personnel sphere is made of a maraging steel alloy that has 10% better strength-weight ratio than titanium. This alloy contains about 30% cobalt and smaller amounts of nickel, chrome and titanium. Two hemispheres were made by casting and machining, and then bolted together, thus avoiding welded joints. The resulting construction is close to the density of water, thus making it easier to move in different depths. Additional buoyancy is provided by cubic meters of syntactic foam. Unlike other deep submergence vehicles that use iron ballast to reach the ocean floor, the buoyancy and depth is adjusted by ballast tanks. The Mir submersibles are 7.8 meters long, 3.6 meters wide, 3.0 meters high, and weighs 18,600 kilograms. The personnel sphere's walls are 5 centimeters thick, and the inside diameter of the working area is 2.1 meters. 3 viewports are provided. The forward-facing port is 20 centimeters diameter. The two side-facing ports are 12 centimeters diameter each. Power is provided by NiCad batteries of 100 kilowatt-hours capacity. Electric motors drive hydraulic pumps to actuate hydraulic manipulators and 3 propulsors. The aft hydraulic propulsor is rated at 9 kilowatts and 2 side propulsors are rated at 2.5 kilowatts each. Maximum underwater speed is 5 knots. Longitudinal trim is controlled using 2 spherical water ballast tanks, fore and aft. Water can be forced out of these tanks as required by using compressed air. Air pressure inside the cabin remains at a constant 1 atmosphere. The air is recycled in a manner similar to that used on board spacecraft, with lithium hydroxide scrubbers removing accumulated carbon dioxide. VHF radio is used to maintain communication with the surface. The units contain imaging sonar units of 250 meters range, so nearby objects can be visualized and the distance measured. The distance to the seabed can also be accurately measured when nearing touchdown. The unit's life support systems have 246 man-hour capacity, or 3.42 days for a 3-person crew. The units are designed for pressure at 6,000 meters depth, and have been tested to 125% of that pressure. In field testing, Mir 1 descended to 6,170 meters and Mir 2 descended to 6,120 meters. Originally, the hydraulic manipulators were covered by a helmet-like retractable see-through visor, but these were removed in a major overhaul in 1994. The submersibles change depth at a maximum vertical speed of 40 meters per minute, so several hours are required to travel to and from deep sites. Finnish-Soviet cooperation. Production of the two Mir units was a prime example of Finnish-Soviet economic and technical cooperation during the Cold War. Bids from Canada, France and Sweden to construct the submarines had been retracted, most likely due to political pressure. In a later interview with SDT, the then Rauma-Repola department head Peter Laxell said he believed that Finland got the permit to deliver the crafts to the Soviets on the basis that the COCOM officials in the USA believed the project would be a failure. Once it became clear to them we actually had accomplished the engineering feat, there was a huge uproar about how such technology could be sold to the Soviets, enough for many visits to the Pentagon. Because of the COCOM restrictions, most of the technology used had to be developed in Finland. The electronics was developed by Holmi. The syntactic foam was produced in Finland by XLOYJ, as 3M, the leading producer, refused to supply the product. The construction, including casting, was done by Lokomo in Tampere, Finland. The level of technology flowing into the Soviet Union raised concern in the USA, and Rauma-Repola was privately threatened with economic sanctions. For example, one concern of the Pentagon was the possibility that the Soviet Union would manufacture a pioneer submarine fleet that could clear the ocean floor of U.S. deep-sea listening equipment, with the possibility of losing its lucrative offshore oil platforms market. Rauma-Repola yielded, and submarine development ceased in Finland. One project that was abandoned was the development of a fuel cell-based air-independent propulsion system. The 122 meters length support vessel the academic Mstislav Keldysh was also built in Finland, at the Holming shipyard in Rauma in 1980. Expeditions, Titanic and Bismarck filming. In the mid-1990s and early 2000s, the Mir vehicles were used by Canadian film director James Cameron to film the wreck of the RMS Titanic, resting at a depth of 3,821 meters, for his 1997 film Titanic and documentaries such as Ghosts of the Abyss, and to film the wreck of the Bismarck, resting at a depth of 4,700 meters, for his 2002 documentary film Expedition Bismarck. 2007 North Pole submersion. On August 2, 2007, Russia used the Mir submersibles to perform the first manned descent to the seabed under the geographic North Pole, to a depth of 4,261 meters, to scientifically research the region in relation to the 2001 Russian territorial claim. The Mir-1 crew, pilot Anatoly Sigalovich, polar explorer Arthur Chilingrov, and Vladimir Grozdev. The Mir-2 crew were international: Russian pilot Yevgeny Chernyev, Australian Mike McDowell, Swede Frederick Paulson. On the seabed, Mir-1 planted a 1-meter-tall rust-proof flag of Russia, made of titanium alloy at OKB Baikal in Kaliningrad, and left a time capsule, containing a message for future generations and a flag of united Russia. If 100 or 1,000 years from now someone goes down to where we were, they will see the Russian flag there. Such Chilingrov soil and water samples of the seabed were taken during the mission. International skepticism regarding the Russian mission was put forward by Peter Mackay, Canada's foreign minister, and Tom Casey, deputy spokesman of the U.S. State Department, who argued that Russian claim of the Arctic has no legal standing. Mistaken controversy. A short time after announcement of the polar expedition, some newspapers tried to stir up controversy by claiming the expedition was fake because some of the footage was from James Cameron's movie, Titanic. A Russian television network had used the Titanic footage as an illustration of the deep-sea vessels in action. They had shown this hours before the Mir submersibles had arrived on the Arctic seabed, and they had pointed out that the footage was from the movie, not a transmission from the site. Reuters did not know this information when it carried the story, and used the pictures wrongly captioned. Reuters later apologized and issued a statement reading in part, "Reuters mistakenly identified this file footage as originating from the Arctic, and not the North Atlantic where the footage was shot, and they reposted the story with correct captions." 2008-2009 Expedition to Lake Baikal. In July 2008, both Mir submersibles began a 2-year expedition to Lake Baikal, the world's largest freshwater reservoir. The expedition is being led by the Russian Academy of Sciences. During the expedition, around 160 descents were planned to the bottom of the lake, which was previously largely unexplored. On the descent on August 1, Russian Prime Minister Putin accompanied the dive in the southern portion of the lake. 2011 Lake Geneva exploration. In 2011, both submersibles were part of a scientific exploration program in Lake Geneva called LMO, in which researchers conducted studies in areas such as bacteriology and micropollutants, as well as exploring Lake Geneva's geology and physics. The submersibles arrived on Lake Geneva in May 2011. Notable pilots: Anatoly Sigalovich,